to all my class 9 students. Welcome to A series. I'm your Aditi ma'am, and of course we are going to study science of your class 9th today. Now you must have enjoying your summer vacations. That's why we are just starting very slowly. Okay, you don't need to worry, you don't need to hush around all the syllabus. We will start this chapter, that is entering the world of secondary science, because now you have officially entered into your secondary school. In the middle school, we used to study science in more of a generic way. What is happening, what is biology, what is physics, how does a car move and all that. But now we are moving on to a bigger level, to a secondary level, where we are going to see how exactly things happen. Okay, earlier we just studied what we know. Okay, what are the things that are there in science? But now we are going to see how exactly those things happen. Why do I know that gravity exists? Do you know why gravity exists? That is the answer we are going to see starting from today. I won't say you'll get all the answers of this universe in 9th class, of course you won't, but this is the most basic thing that you will start in science today. I'm your Aditi ma'am, and on this channel Deeksha Vedantu, we are going to cover all the chapters of class 9th, all the chapters of class 10th. So make sure you subscribe this channel, and there will be a link in the description for the WhatsApp channel. Go join that WhatsApp channel as well. Okay, now what we knew until our middle school, now in secondary school we will understand how we know it. We will explore the reasons behind it, and hence the book is called Exploration. Okay, now what exactly will we study in class 9? Lots of new things that you haven't seen before, lots of things that are new to you, lots of words, new terminologies, new reasons behind all those basic things that we see in our everyday life. Right? So how do we study this is the main question. So with this new NCERT, I like this a little bit more, because what we are going to study in this is how exactly science works. Not what science is, what is the science behind this, no, but how actually that science is working. Right? How exactly scientists think. You and I, maybe we are normal people, right? But there are scientists. When an apple fell from the tree, how does Newton even think that why this apple is falling downwards? Have you ever stopped and think, why when I jump I come downwards? Why do I not fly up in the space? Right? Those are the things, those are the minds that we have to read, how to capture those small things that we as an ordinary human, not a science being, skip. Right? Then we will move on to how do we study science? Why do we study science? Right? There are lots of questions around, and I used to ask my teachers, right, ma'am, why do I need to know about sine theta and tan theta, right? Why do I need to know how this machine works if my dream, okay, is to become a doctor? Why should I know how this particular machine works? Or what will I do knowing what is the slope of a building? How does a building being made? I want to just work as a doctor on the body, human body. But that's what the case is, right? In 9th class, these are the foundation classes. These will make you ready for everything that you can do. And after 10th, then we'll choose a specific path that, okay, I don't want to know how building works, how building is made. I want to know how human anatomy works, right? And that is why for these 2 years, you have to study basics of everything so that you can get to know what I actually really like. Do I actually like building things? Do I actually like working on human body or not, right? So all those things we will study here, and that is the answer to the question, why do we study science, right? And next, is science just facts or a little bit more? When I'm walking, I'm experiencing a force of friction. Then what should I do with this? Okay, I'm experiencing friction. What should I do with this? Exactly those things we are going to study today. Okay, because let's say when you think of friction, it actually helps to solve so many real world problems. And one day, some of you will become an engineer. The phones you are using, actually, when you touch the screen of your phone, when I touch here, it's actually working because of friction. and I can design new things because learning that, right? So all those things is exactly why we study science and why it is more than just facts. Okay, now let's dive a little bit into science stuff. Okay, let's start your journey of becoming a scientist if you want to, and if you don't want to, let's start off your journey of getting a little bit more common sense, let's say. Okay, now first thing we have to see in science is models. What are models? Let's say you click a picture of me or you take a screenshot. What is that screenshot? Does that screenshot tells you what my height is? Does that picture of me, I have an image of me, does that image of me tells you or tells anyone what my characteristics are, what my likes are, what my personality is? No, it's just my model, right? It's just something that simplifies me, that shows who I am, how I look, but does not show my complex structures, how overthinker I am, how oversmart I am, but how it shows a simplified version of me, right? What are the things that makes me mad? It doesn't show it there. It's just a model. It's a simplified version of reality to make sense of its complexity. Right? When you click a picture of a car, it doesn't show you how much horsepower it has. It just show you the car, how it looks, its color, and a little bit of background. Right? But the complex structures of what went into the engineering of this, what went into the engineer, what that engineer study all through his life to build a horsepower of 700, that didn't show up in the image, because I just want to see what's the color of the car. So I click a snapshot and I leave all the complexity behind, right? Now, we do that in physics as well, right? When I draw a diagram of a heart, I don't really go deep into what are the vessels, where are the cells are, where are the tissues in the heart. I just see the basic functioning of heart, right? That's why I just draw the diagram of heart. That is it. So that is a model of heart, and my heart doesn't look like this, right? It does not look like this. It actually looks like this. So we make a diagram of heart to actually understand the science behind it. Similarly, you have globe. You have seen globes. It does not tell you how big of a earth is, how complex the core of earth is, how hot the core of earth is, right? But it tells you how earth actually looks like, where are the countries, where are not. It does not tell you what are the conflicts between those countries, who is the president or the prime minister of that country, but it just tells you the position of that country, and that is something we need to know for some basic thing, right? So globe is the model of actual earth. Sphere or dot or bones, when I say I am made of atoms, so let's say I make myself, or I make a picture of myself. Yeah. So this is a person. Okay. This is a person. That's a bad person. How I'll define? It's made of atoms. So it's made of atoms. So I'm depicting atoms. I am depicting atoms with the help of what? With the help of dots, right? So dots are the models of atoms. Understood? My picture is a model of me. Dots are the models of atoms. A diagram is actually a model of a heart. A globe is actually a model of an earth. Understood? That's how that we do this to make the complexity of science a little bit easy to understand and focus on one main part of that thing, on one main part of that function, of that car, of that heart. Right? Okay. Now, moving on to the next thing, we have how do we study science, right? Because see, everybody will study science. There are millions of students in 9th and 10th across the whole of India or the world that are studying science, right? But how do we actually study science? Not all of them will like science. Not all of them will eventually take up science in 11th or 12th. But how do we study science so as to make it a little bit more easy? And if you actually like science, if you actually like asking the questions why this world works around us, how this world works around us, so you have to know the right approach to study anything, right? Whenever we start a work, the first thing is how to do it in a perfect good way, how to do it in a right way, right? So now let's look into how to understand the science in a right way. Let's say I am Newton, and I'm sitting under a tree, and an apple fell, and I was like, oh, this is tasty, and I'll just eat it. So imagine a difference. There is a difference between me and Newton, right? Between you and Newton. Now what Newton did, Newton asked the question. Asking questions is the main agenda of science. Newton asked the question, why did this apple fell on the ground? Why didn't it go into the space? Why didn't it go out in the space? Why did it fall down? And that is the basics. It's the basis of most important theories, laws in the whole world, whatever Newton did, right? So asking questions is what you need to do anytime you read science. This is the first thing you have to do, asking questions. And we'll see how to do that as well, because I told you it's basic. See, asking questions is one thing, but asking right questions is where we lack. Okay, then you've asked a question and then you came up with an imaginary answer, or you did some testing. You saw that every time something drops, it comes to the ground. So that is testing, right? And third, then you said, okay, there is something that is pulling that apple down. That is, my friend, conclusion, right? And then you say, what exactly is it? Maybe it's gravity. Now I'll tell you a little bit of advanced science. Okay, so Newton said it's gravity, but you know Einstein, right? So Albert Einstein ji came and he said it's actually not gravity, it's space-time fabric in space, something. Just see, so Newton explained the same thing with gravity, but Einstein explained the same thing with space-time curvature. That is improvement. Both theories are true on their own. We use them wherever we think those theories fit, but this is what is called improvement. So asking questions is the first thing that you need to do at this point, because we are just babies right now. Okay, you not a baby, but compare yourself to a PhD person who has a PhD in physics, right? I have a master's in physics. You are just in 9th class. What you need to read, what you need to learn right now is how to ask the right questions. Okay, I have a scenario for you. Okay, you are playing cricket. Okay, you play cricket and you, how do you say, what are the terms of cricket? I don't know. Okay, you hit the ball with the bat and everyone says, oh, it's a 6, or maybe it's an out. It's a 6, it's an out. What is it? You'll have to wait for the ball to touch the boundary, right? But if the ball is in that air, I'll get Doraemon and I'll stopwatch and it's in the air. And I ask you, how do you figure out if the ball will hit the ground, if it will be a 6, or if it will be a catch, if it will be an out? Then you will start asking me questions, right? Now in that, do you think these questions make sense? Will you ask me these questions? Ma'am, okay, it should be a 6. What is the brand of the bat? Will you ask me that? Will you ask me? Of course, at some level that matters, okay? But on the basic very level, does it matter what is the brand of the bat? Does it matter what is the color of the ball? Or does it matter what's the amount of grass on the field? Right? Now you who are like core cricketers, you'll say that, ma'am, some of these things do matter, right? But do these things matter more than these things? The mass of the ball. Of course, if the ball is less heavy, it will go farther, right? Or if the speed and direction in which the ball is thrown, if the ball is going on the farther level, okay, so that I know that cricket ground is not totally round, okay, I know that. So sometimes it's oval, so if it is going to the direction which is like longer, of course it can be a catch. But if it's going in the direction which is like the ground is smaller, the probability is that it might be a 6. Right? So all these things matter. These questions matter way more than these questions on a basic level. Now, of course, these questions matter. When you are a Sachin Tendulkar, right? When you are MS Dhoni, you do select a bat basis on its brand, if it's of a good brand, if it's not of a good brand. But while in the ground, he hit a ball, the commentators never talk about, oh, it's that bad, it's a Kashmir willow bat and it is good, so it will be a 6. That does not define will it be a 6 or a catch, right? But in here we say models, right? Now we study models. It's a description or less complex version of reality. Now, if these things matter, air resistance also matters. Can I measure air resistance while the ball is mid in the air? Okay, I know if the air is more, if there is wind, the ball might be a catch. The ball might not reach the boundary if it's in the opposite direction of the wind is up in the opposite direction of the ball, right? But those things we ignore to make it a little bit more, let's say, fundamental, to focus more on the strength of the player, more on the mass of the ball, more on the speed and direction of the ball, rather than air resistance or grass on the field or the brand of the bat or the spin of ball and the stitching of the seam. There is seam on the ball, right? So will you say that, oh, it was not a 6 because the seam, the stitching of the threads on the seam were not right? Will you say that? No, right? So we need to ask correct questions to reach to an answer which will give us the concepts that we need to understand the basic fundamentals of science, right? You wanted to understand why is this a 6 or a catch, so you go and you ask the batsman, did you use your proper strength, what was the mass of the ball, in which speed or direction you chose to hit that 6, why, if you should have hit in this direction than in the straight direction, it might have been a 6, but now it's a catch, right? So you don't talk about the seam of the ball, the seam of the threads of the ball. And that is why in science, asking the right type of questions matters a lot more to reach to a particular conclusion, to reach to an answer that actually helps us understand science. Okay, now moving on, the next we have language of science. I live in Punjab, so my language is Punjabi. Right? You might live in Bangalore, so your language is Kannada, or you might live in UP, your language is Hindi, or your language is Assamese. So that's how we have all the different languages in India. Now, science has a very particular language. We know that, oh, this person has so much force in him, right? Because he goes to gym. But in science, force means a completely different work. I am working, right? I'm teaching you, it's my job, it's my work. But work has a completely different meaning in science. Energy, like I drank Nimbu Pani and I got energy, but energy has a completely special meaning in science. So in science has a completely different meaning, a completely different values for what it holds for those words, right? So whenever you see a capital V written anywhere in a science book, you know that it is defining velocity. F, you know it is defining force. W, it is defining work done. And that is why science has a very special language. Okay. Now, science also has a bit of a maths in it. Why? Let's say, you know this formula, right? So, velocity is equal to distance or displacement, whatever, divided by time. At this moment, let's just ignore the difference between distance and displacement. Okay. So, this is a basic formula. Correct? Now, what does this formula depicts? That velocity depends on distance upon time, divide time equal to. So what are all these things? These things are mathematics, right? Multiply, divide, equal to sign, and how these things are related to each other. How my velocity is related to distance traveled and the time in which that car traveled 5 kilometers, let's say. Okay, so maths helps us to define relationships, helps us to describe relationships between different quantities. Okay, now that was the basic language of science. Now one more thing, very important, is that I am sitting here, okay, and I tell you, get me 10 kg of tomatoes or whatever, right? Tomatoes, okay, and then you go but you are in Germany, okay. If you go there and you ask for 10 kg of tomatoes, then they'll be confused. Or let's say in America, they'll be confused because they don't use kgs, they use pounds, or they use some other measurements. So every country, every place on this earth, let's say in some part of our country, we get bananas by dozens. But in some part of the country, we get bananas by kgs, right? So there are different kinds of units that we can use to measure things. Now, what is units, ma'am? So units is basically, see, I told you 5 kg of tomatoes or 5 kg of bananas. Now what is this kg? Can I tell you, like, get me 5 meter of tomatoes? Can you do that? If you go and ask your vegetable uncle to get you 5 meter of tomatoes, he'll probably slap you. Okay, or he'll probably laugh on you that who is teaching you, and you'll say Aditi ma'am is teaching me, then that's a really bad influence of me, okay, bad image of me. So you won't say 5 meter of tomatoes, right? But you will say 5 meter of distance, right? 5 centimeter of my hand, 5 meter of distance I traveled, 5 kilometer of distance. You won't say 5 kg of distance I traveled, right? So every quantity, distance, weight, time, every quantity has a different unit with which we define it. If I tell you get me 5 tomatoes, you will say, okay, I'll get you 5 tomatoes. But the 5 tomatoes, what do you think I told you? 5 number of tomatoes, 5 kg of tomatoes, 5 gram of tomatoes, 5 quintal of tomatoes, right? So you'll have to ask me 5 what? 5 number of bananas or 5 kg of bananas? So that is what our units are, okay? And it is very important to use the right kind of units, because that is a very good case, and it is there in your NCERT as well, that a plane was there, a plane was flying, and the person who has to fill the fuel and whoever goes there, they didn't tell what unit of fuel they want. Let's say they ask, get me 25,000 kg of fuel. Okay, this is what the guy meant, that this is what I want. Okay, but the person who was filling the fuel, he understood that he wants pounds of fuel, right? So he, instead of 25,000 kg, or let's say 15,000 kg, 15,000 kg of fuel, okay, you want. Now he understood that he doesn't want 15,000 of kg of fuel, he wants 15,000 pounds of fuel. Okay, now fuel and pounds are completely different units. In between this, 15,000 kg and 15,000 pounds are very different. Okay, 15,000 pounds will around be, let's say it's almost around 1,000 or 10,000 kg of fuel. So now your aircraft is in air, and you know, but I filled 15,000 kg of fuel. And it was like, kg? But I filled only 15,000 pounds of fuel. That's only 10,000 kg. So that 5,000 difference is why they needed to land immediately to save their lives. Okay, and that is, my friend, it is very important. That is why it is very important, beta, to use proper units. Okay, right? Now, these units have a standard measurement to study science. When I say 9 meters, when I say 15 ampere of current, it means same here, it means same in Germany, it means same in America. So if I'm working on some very important experiment and the other scientist is also working in Germany on the very same experiment, we are totally aligned. Okay, the length is in meters. So the SI units are where we study the standard unit system for science that is used in experimental science. Okay, so physical quantities are what? We measure length, right? We measure mass, time. So their SI units are SI units, remember. Okay, so these are meter, right? These are kilogram. Whenever you say my home is 5 kilometers from my school, I'll say, okay, no, tell me in SI units. So we know that 1 kilometer has 1,000 meters, right? 1,000 meters, and SI unit of length is what? Meters. So I will convert this 5 kilometer into 1,000 into meters, which is 1,000 into 5, that is 5,000 meters. Okay, and I'll tell you, okay, if you want to know in meters, that is 5,000 meters. You want to know the SI unit, that is meters. Okay, then for mass it's kilogram, for time it's second. Then you will study electric current. For electric current it is ampere, and we denote it by A. Okay, ampere. Then for temperature, it is Kelvin, that is denoted by a simple K. Then we have amount of substance that you'll study very early actually, that is mole, and we write it by MOL. And luminous intensity, that is candela, that is CD. So mostly you have to remember till fifth. It is very important to remember all these stuff, okay, to remember all these units. Then length, meter, mass, kg, time, second, electric current, ampere, temperature, Kelvin. Understood? And their unit. So whenever you say S is written, you know it is 10 seconds. Whenever you say 10 kg, it's weight. Okay, whenever you say 10 meters, it is length. Whenever you see 10 Kelvin, you know it is temperature. So that is how you differ between units, and these are same throughout the world to understand science. Okay. Now moving on to next, we have some of the basic definitions. Okay, in this science we studied laws. Now ma'am, what is law? A law is a scientific term, let's say a scientific theory, not a theory, it's just, let's say, a law that describes what happens in nature, often in a fixed pattern. That means Newton's laws of motion. That means in every case, whatever the conditions are, Newton has already told us. Okay, in all those conditions, if all those conditions are true, then in all those things, Newton's laws will be applicable. They won't be false. Laws are something that is true in every manner, everywhere on this earth, around this space. And if it is not true, then there will be mentioned some conditions. The temperature is, if the temperature is 10 Kelvin, okay, if the temperature is 100 degrees Celsius, the water will boil. Now this might be true on earth but may not be true on moon. Right? So they will define that the water will boil at 100 degrees Celsius on earth, and whatever these conditions are, right? So Newton's laws of motion, how a car travels, how it stops, what is the acceleration, what is the velocity, all comes under laws, right? Then we have theories. Now what theories are more explainable nature of laws and whatever is happening in the nature. Okay, a scientific theory explains why and how something happens. When I walk, I experience a force, I experience friction. But why I experience friction and how I experience friction, what is the direction of friction force, all those things are included in theory. So the atomic theory of atomic theory explains how molecules are formed. Okay, so it will completely explain you that there is an atom, another atom, it will overlap, then it will form molecules, it will have this property, all that will come under theory. Okay, then we have some principles, just like you have some principles, right? And whenever someone says, okay, hey, let me cheat in the exam, you're like, no, I am very rigid on my principles, I won't cheat. So not cheating is your principle, and you will apply that in future circumstances as well, right? Now just like that, science also has some principles, a general rule or an idea that helps us to understand and apply science in different conditions as well. Okay, you are not cheating in this class, in future maybe you are not cheating as well. Why? Because your principles are strong. So just like that, science has some principles, some rule which it follows, and with the help of that we describe science, we understand and apply the science in all different conditions as well. Okay, for example, scientific example is principle of conservation of energy being applied when climbing up the stairs. Now conservation of energy is, energy can't be created nor be destroyed, but it can be converted from one form to another. Now how it is applied to climbing of stairs? See, I ate some stuff, okay, now that is converted into muscular energy. Okay, then that muscular energy, with the help of that muscular energy, I will climb the stairs. So chemical energy being converted into muscular energy is why we eat food, and that is the principle of conservation of energy applied in climbing of stairs. Okay, because the energy remain conserved as it converted from muscular energy, chemical energy to muscular energy. Then understood? Okay. Next, just recap that. So law is what happens. What is happening in this world is a law. Newton's laws. Motion. Theory is why it happens. It gives a complete reason of why this thing is exactly happening, right? Then principle is a general rule. We have this rule and we will apply in all different conditions, in all different circumstances. That is your energy conservation. Okay, almost the chapter is completed, and we have one more thing, that is predictions. Now, predictions is a very important thing in science. Why? Because continuously, there are lots of experiments happening in science, and before we start the experiment, we like to predict, right? That I am doing this experiment to achieve this result, and I predict that if I do this in this way, I will reach here. Right, if I leave the home by 8:55, I predict that I reach my school at 9. Now, if that's true, then science wins. If that is not true, because that is a little bit delusional, but if it doesn't win, then next day we will improve ourselves and we'll leave our home at 8:40. Right? That's exactly how science works. When all these laws, what is happening, theories, why is it happening, and all the models that is used to understand or less complexify the science all comes together are as well established. They allow us to anticipate what will happen under new or different conditions. When we know what usually happens, why it happens, we are able to predict that if I change this circumstance, if I change this condition, then I predict that this outcome will come. Okay? That is what prediction in science is. Let's say we predict weather, right? When weather companies, they predict that today it's going to rain. Why they say that? Because they measure humidity, they measure temperature, they measure all sort of things, and they compare it with the previous time it rained. And if it matches with that, then it will rain. If it does not matches, then it will not rain. Right? Now, sometimes predictions can be false also. Sometimes, a lot of the times, weather does not go as it's predicted because it's continuously changing. Right? Because the conditions are continuously changing. Motion of objects. Again, I told you, leave the home in your car and you can predict that this is my time, this is my velocity, and this is the distance I can cover in this much of time. That is what we use in motion, right? We read in motion chapter that all these things happening, right? So, if prediction matches your observation, science wins. But if prediction does not matches your observation, we improve the phenomena of science, we improve our knowledge, and we go again and we do the experiments again, right? Now, on that, see, Varsha is there. She says, oh, look, it will rain today. Now, Meghna is like, why are you saying that it rains today? What was the sky like when it rained last time? See, she is combining predictions with, she is doing the prediction, but she is asking the right kind of questions that we studied earlier, right? What was the sky looked when it rained yesterday? Were the clouds white or were the clouds grayish? If they are grayish, it might rain. What is the humidity today? It's 78%. Was it above 80% before? If it was, then it might not rain. But if it was less than 80%, then it will rain, right? It might rain. What is the speed of the wind and the direction? If there is too much speed, the clouds might fly by over us, right? But if there are no speed of the wind, the clouds might stay and it might rain. Is the temperature dropping like it was dropping the last time? If it is dropping, if all the things match from the last time, she predicted right. If it doesn't, she predicted wrong, and she will improve herself. She will improve her statistics next time, right? And just the last thing is the whole science is connected, my friend. The whole science is connected, bacha. When we talk about science, we do not just talk about biology or chemistry or physics. These are the things that we as humans made to classify the knowledge better, to understand the knowledge better, right? But in this proper, on our earth, everything is connected. In my body, biology is happening, chemistry is happening. I walk, I use physics, I calculate something. When I jump higher the next time. Maths is being used. Okay. Now all these things, let's understand in an example of mask, right? we all worn mask in COVID, right? So what was happening in mask, when they made mask, every department was there. Physics department was checking what is the size of those particles, size of the holes of the masks should be, so that the corona particles does not pass it, only the air passes, oxygen passes it, right? Chemistry, what is the material of that mask, what should be the material of the mask to maybe kill the virus and not let it enter into your mouth, into your breathing system. Biology was studying about that virus. Okay, what if that virus clinged to your mask? What should the mask look like? What should the biology of that, what is the biology of that virus is, so as this mask protects us from that virus. And math, what is the efficiency of this mask, how much oxygen it is letting pass, it is letting it pass through. What if virus passed it the last time, now we have to improve it, so the efficiency of mask is improved using the math. The percentage of oxygen is passed, the percentage of virus stopped, right? That is it. The first chapter of class 9th is complete. I know you are enjoying your summer vacations, but this time is also something that you need to be very careful about, because I know you want to score 95%, right? I know you want to score 95% in 9th and in 10th, and that starts now. It's a battle, it's a long journey of 2 years, but they will pass right away like the last 2 years did, right? So we have to start today. Just start. It's a basic chapter, how we understand science. Next, the motion chapter is already uploaded. Go watch that. It's really good. I'm really proud of how I taught this time. Okay. And next we will be coming with more lectures of 9th as well as 10th on this channel, lives as well. So make sure you subscribe this channel. And the first chapter is done, entering the world of secondary science. So subscribe the channel, because we are going to give class 9th and 10th full series. This is a series, class 10th is OG series, for completely free, bacha. Okay, we know how much study is a basic right. Okay, and you're already paying your internet bills. We don't want to charge you more for that. And that is it for this chapter, for this series. I'll meet you in the next one. Go watch the motion chapter right now. You have to complete that very early, and when I'll come live, make sure you come with us, as with me as well, and you watch and you ask the questions, ask the doubts, whatever you want. All the schedule of the live will be uploaded. There will be a link in the description. Go join that WhatsApp channel, and I'll meet you in the next video. Bye bye.